Yeah,
we can't get it.
Right.
Okay.
Yeah, so it's recording now, and now folks behave now. We are recording.
That means you, Kyle.
So guys, who's coming to ONS next week? I know Kyle is not. Anybody else in the call today?
Yeah, thanks for making me feel bad again, Madhu. Yeah.
I'll never miss opportunity, man. I never miss opportunity.
Oh my God.
No, dude, trust me, they're gonna miss you, man. Because, you are the guy.
No. You guys carry the torch. I would have loved to have been there, but I just can't. There's just only so much travel a guy can handle.
I know, man. I mean, the one reason I could attend is because it's happening in the area. It's not nowhere.
Yeah.
Well, I gotta go to Boston this week. Come home for a night and then go to that. I'm just like dreading it. Well,
Yeah.
Brent, you don't have kids, man. You're okay.
I got a lot of cats, though. A lot of cats.
Yeah, that's true.
Like, here's a cat. See? Cat.
Oh, look at all those cats.
So nobody's going to ONS?
Other than you guys, I think that's it.
Did somebody say they were? Matt, was that you, buddy? Oh, I heard somebody say they were going. Oh, okay. Cool.
I'm not going, though.
Oh, you're not going?
Well,
I won't be able to go either.
Yes.
It's actually too expensive, man. It's $1,500. It's too expensive for that. But it gets filled up. And last year it was like a marketing mela. And this year if you look at the keynotes and everything, it's like they ripped off all the marketing bullshit. And then it's purely. I like this time's keynote and all the presentations. No more marketing from the vendors.
Yeah. Yeah, here's where we cut and start the recording over.
Last year was horrible, man. I had to say, it was horrible.
That was Kyle Mestry from Cisco.
Yeah.
Cisco keeps doing that. You heard
but
it here.
If you look at it, right, Cisco has never given anything like this in ONS. I mean, I have to respect that, where they have never come and give such a marketing pitch there. I feel it's very good.
Yeah, I think Colin, what's his name, talked there last time. I like that dude. I think he's one of the main reasons we have daylight.
Right.
Oh, yeah? You do like him? Because I've always been impressed, but I think that's a great shooter. The talks are great, though. I mean, they got Martine up there. They got, so if anybody's in the Bay Area, and either way, we'll be out there, and, swing by a lot, swing by the hat. What are we doing? We've got the SDN Idols thing, so we've still got to figure out what to really do there. Some dude did the demo earlier.
Actually, we have three things, right? SDN Idol, the demo booth, and also the developer track for Open Daylight. It's a lot of activity on ONS, and we are like completely swamped with that. Completely.
Yeah, it's because the demo thing, we still got the idle thing we've got to figure out kind of what we're gonna demo.
So, dude, we can get started, man. When Brent, if you want to start up, we start up. You have the ball, so you're going to start it.
I don't have to. So I know we had a couple things. Everybody kind of throw out what, I know we were going to talk about, Matt, maybe, do you want to lead some of that? You said you've been doing some, a deep dive into OVSDB comparison with NetComp, kind of help everybody get their head around that. You want to maybe kick that off, buddy?
Yeah, so I'll preface it with saying that I've only really started on the Yang side. I got interested in it because of when TLF presented to us at Network Field Day, they were talking about Yang and NetConf a lot, and I know kind of how NetConf works on a high level. Obviously, like what drew me to OVSDB originally was how very similar it was to like a database language, because you have, updates and mutates and all of these kind of things that just really made sense to me. NetConf is sort of centered around basically bridging the gap between that and keeping your CLI kind of syntax intact, so you don't have to just totally shift gears. So there's some caveats to be made there. I think it's inherently not as object-oriented as I probably like it to be, and I think a lot of the folks in this call are used to dealing with, but it's still interesting. There were a lot of folks that actually got really, really psyched about Yang, so really the comparison is just in its infant stages, and I just wanted to, since I've been working with sort of both on a high level, I wanted to make sure that there was some kind of comparison out there so that people know what the roles were for both protocols. But yeah, so Yang it seems to be like the most of the interest around Yang comes from doing modeling for configurations. So it is very network configuration specific. But the thing that was told to me by a few colleagues and TLF, they said that it can easily be used to if you wanted to run Yang as your basically general descriptor language. It's hierarchical and modular enough that you could do that and still do OVSDB on the side or whatever REST on the side, whatever you wanted to do. So that's the part I really wanted to dig into, and I haven't yet today. It's been like a day. So that's where I'm at. I'm just trying to get parity between the two.
So Matt, is there any document you want to share or anything you want to present, or is it just pure talk?
No. Like I said, I don't really have much to share yet. I mean, I have the links to the RFPs if you guys like to look at that, but that's about it.
All right, sir. All right, thank you. So actually, the question that Brent asked on Twitter, right? I will let him go deeper on that, but I have my own personal question on that, right? Where we understand JSON is coming from the DevOps side of things, where now all applications out there use JSON as their primary communication mechanism, where they use it to exchange data. And Yang NetConf is mostly the network-centric folks, right, looking at it from a different angle. Now with SDN trying to bring them together and now trying to get these two worlds meet together, right? What do you think will be a better approach for folks to start playing with? Whether it's going to be NetConf-based one and take it towards SDN side, or take the JSON-based one and bring it to the networking side?
So this actually, it's funny, this kind of goes into the conversation you and I were having for the call. I think that in terms of bringing programmability concepts into the light where it's not really prevalent right now, like, I work for a Cisco partner. I have a lot of colleagues, really smart folks, but all they know is CLI. They don't understand scripting or programming or anything like that. And jumping to the example that I'm talking about, I have a pair of Nexus 9000s in the lab, and I was playing around with the API, and I was mentioning to you, it's not that complex. It's actually really just an XML wrapper for command line. Now, it's not SSH scraping, because if it was, then I would hate it. But it's still not a huge paradigm shift in terms of configuration. You're still basically sending show IP route to the switch with an XML wrapper around it. Now the response is a little different also, because instead of having, like, I don't know if anybody's ever dug into like the XML that ASDM uses to send to ASA. So basically that's command line inside of XML for both the request and the response. So it's really not useful. It's basically scraping, just it happens to be inside of an XML tag. Big deal. The API for the Nexus 9K pulls down a little bit more than that, and it actually parses each little property into its own little property. That, I think, is low-hanging fruit for traditional network folks. So to answer your question, I think that even though my preference, coming from the dev and database background, prefers OVSDB because it has such similar functionality with that, I think that in terms of just bridging the gap between totally network-centric, no scripting, no programming guy, NetConf has a leg up because it doesn't try to change everything that they know about configuring devices. It basically just says, here is a nice transport for carrying your configuration that you're dealing with, and here's a list of operations you can do with that. I don't have the RFC in front of me, but it's like get config, edit config, basically remote procedure calls, which is cool because it starts to kind of turn the gears in their head and get that running. Now, eventually, if you go down that path long enough, you'll understand the shortcomings if there are for your implementation, and you'll move in a different direction, maybe study up on OVSDB. I mean, that's kind of the path that I see in terms of getting folks that don't know any of this into this area. It's nice to have at least some kind of tool that's sitting in both sides. You know, so we might not think it's as robust as we want it to be, but it's that low-hanging fruit for those type of guys.
Oh, got it, man. That's a good explanation. So, my own curiosity, right? Others can jump in, but my own curiosity. So, say you're talking about the NetConf and the Yang approach, and getting the network guy into the programmability world makes a lot of sense to me. Is right. But I haven't played with NetConf or Yang much, right? I'm wetting my feet myself there. Does it kind of lock the customer into one kind of vendor where you have this show a period kind of thing where you try to send information, and the information that we get back is kind of a device-centric or a vendor-centric approach. While if you don't have a very standard-based open data out there, it's very difficult for folks to come in and to make it vendor agnostic or vendor neutral way of accessing data, right? So when you look at NetConf and Yang, I know the specification itself doesn't preclude anybody from going from the specification doesn't lock into a vendor, but where is it taking towards? When you start using NetConf and Yang, do you get logged into a vendor specific data, or is it like completely open, and the way folks are approaching that?
So that is supposedly what Yang is supposed to prevent. So just like we have OVSDB transport, that's what's defined in our now RFC. We also have schemas that we have to adhere to for specific implementations. I think Yang is meant to supply that functionality in terms of the implementation specific syntax. Let me find a video for you guys real quick.
Yeah, and while you're looking for that, so I almost see us kind of going. There's an interesting call yesterday. I don't know if anybody got a chance to listen to TWS, but it's almost that ODL, like the promise of Yang, is we can feed in whatever you want, everything's extensible, and so really what it feels like to me, to some sense, is we're saying there doesn't need to be anything with the northbound, and everything's going to, we can fragment everything out. And so it's whatever the vendor wants to implement, the vendor implements. I don't know if that's a good thing or a bad thing, but I don't know. Madhu's comments kind of got me thinking from yesterday.
I think it's supposed to have some common.
So I'm not trying to promote KLF specifically, but this is the video that I was referring to that allows some cool like mixed configuration thing. They used their demo to show us that it was pretty easy to switch between Juniper style configuration and Cisco style configuration in real time. So if you had a bunch of Cisco devices but your engineers were all Juniper trained for whatever reason, then you'd be able to hit that button and it switches, and it still works. You can have your administrators log into their NCS system and they enter Juniper commands, but it translates to Cisco commands using Yang, basically, on the back end. So this is just one implementation. I've not used NCS. I don't know anything about it. I'm not trying to push it out there. But
I wonder how much of that is TLF special source though, because when I've been looking at Yang previously, and again I haven't really given it much time, as I understood it, the one thing that is really missing from this is kind of like the MIBs that we have in SNMP that allow us to do device neutral things. So we can set host names and stuff using SNMP, no problem. We can do that on a server, we can do it on a switch. Awesome. That level of abstraction didn't appear to exist in Yang for me, and that was kind of a problem. But maybe TLF are doing something else, and they know something that I don't.
In fact, yes, that's the exact concern there, right? So from a point of view of RPC call that we are talking about, right? Defining RPC is not a big deal at all. I mean, we can define any other mechanism, but if you don't have a standard way to access standard data, right? If you don't have if you look at the architecture, the architecture itself must come with this standard mechanism to access standard data, right? If you don't have that, if you make it very flexible, say augment the Yang the way you want to, and then convert in the backend, what is going to happen is it's going to be mostly like the most used one will become the predominant one, like the AWS today, right? Where the Amazon service become the de facto standard now, and everybody started using that. So I don't want that to become personally. I don't want it to become that way. At least on the OVSDB side, the reason I like that is we have this RFC, as I said, this is RPC mechanism. On top, these are standard schemas like the hardware weighted schema, we have the open message schema, and folks are implementing that schema, right? That means when I write my application on OpenDaylight or anywhere, I can depend on that one schema and guaranteed that the folks on the other end is going to work, right? So I have this standard data being exposed by the standards essentially. Without that being there, I'm really worried that this, even though Yang is a good mechanism for RPC, if you don't have a standard data access, we are going to going into this world of non-standard MIBs and proprietary MIBs and so on and so forth. I mean, it is my concern. Maybe it's the lack of my understanding more than anything else. That's why, Matt, I really had to get some help from you guys to understand it better.
What I have seen so far in this area is that in the IETF, they are standardizing some of the protocol Yang models. So there are RFCs that have the title a Yang model for protocol X. So maybe one avenue is that for people who really care about something being open, just go to the IETF or somewhere and then standardize a Yang model and publish it, and then if it's considered a standard, then people should adhere to it.
And that's what we're doing already. We're using IETF-based Yang models. I think the issue or the concern that Madhu is expressing is that, like SNMP MIBs, there's an extensibility component, and then nobody ships a standard one without extending it.
Yeah, I mean, yes, exactly. That's my concern. Yeah. And how much that concern is a legitimate one, how much is just my my weird worry about the SNMP world?
Hey, Madhu, I pulled up a quick comparison between the two because I kind of needed to see something a little bit more concrete. It might help. You mind if I'm not sure at the desktop here?
Please do, sir. Please.
All right, buddy.
Hey, Matt, by the way, you are on mute. I'm not sure whether you want to talk or give any inputs.
Not necessarily, just force a habit.
I hope we are not trying to poke holes or anything. We're just trying to understand better.
So can you see the screen, guys?
Yes, sir.
Okay, cool. So this is kind of, I mean, I guess the first thing that jumps out definitely on Yang is it's very, XML. I don't know, because I think when we start talking about what a network engineer is going to do, it's simpler is easier. So I don't know. I mean, personally, when I read the two, I'm curious what you guys think. But when I read the two, I mean, I've gone through the Yang or schemas for F1.3 a whole lot, and I mean, some of it's just it has these kind of pointers where it's pointing off to something else, and it just doesn't do it for me. It just doesn't make a whole lot of sense to me. But JSON, I think, is it's pretty easy to read. It makes a lot of sense. I don't know. Just on the surface, simpler is going to win, and I mean, I'm kind of an idiot, but
So one of the things I'll point out, and I've looked at this before, in JSON you can't actually enforce a schema, whereas in XML you can. You can lint against the schema. You can check that what you're writing is actually okay. But in JSON,
why are we even writing it though? This is an issue. This is like how you transmit stuff. This is not something you should be coding on or writing directly, really.
Well, these are data models, right?
There's no way you
Models
should be
that
doing
we-
it directly.
So Maria, maybe do you mind expanding on that a little bit, buddy?
Who the heck cares what you use underneath? It's what power it gives you. And I'm not trying to defend Yang because I don't like XML, but I mean, looking at these two, it's pretty obvious to me which is more like readable and usable by humans. But I mean, the overlying abstraction is what's important, not how you transmit it.
Mm-hmm. No, I mean, I think that's valid. So what about tools and stuff? That's another thing that I was thinking on, just kind of comparing the two. I mean, there's obviously tons of tools and libraries.
Brent, one thing I want to tell is these two, the comparison you're doing for human beings, these are not meant for human beings, right? These two are meant for some algorithm or language to parse them out and consume it, right? Yeah, it might look hard on some humans to look either one, but who cares about humans looking at this one, right? Really don't. Nobody cares about it. All we care about is how programs are going to make use of this one, right? That's the end of the day. That's the question.
Right.
And I get what Matt's point is. Yang is trying to get the network engineer get into programming, while the JSON-based schemas is letting the DevOps guys get back into networking. Right? It's like two different worlds. Those who get comfortable with what, they can come back to one another. Right? I completely, totally get that. My discussion was, my concern was mostly not with JSON or Yang. Is mostly about the basic principles and the basic idea behind the Yang or the OVSDB like schemas bring in, right? Like vendor lock-in versus non-vendor lock-in mechanisms, and that's where Dave's point really catch my attention. Where where is the standard? If the standard is there in the IETF, I'm happy they are standard, but for the folks following that, or they are just taking the easy way route of extensions and if the moment you go with extensions as the primary mechanism, again we are failing. All of us are failing. We are going to the exact same notion of SNMP MIBs having extensions, and that's the only thing that works.
So there needs to be some kind of standard that comes out after the fact that defines specifically what constructs we're talking about. How do you describe a VLAN and Yang? Something like that. Right,
and the standard, it'd be good if everybody adopts the standard. We don't want a minor tweak. That tweak will work only with a specific vendor network management solution. That is exactly the problem we face with the SNMP world. So we all know that, right? Where yes, specific demos will work. Guys can say, I can translate between Juniper and Cisco and make it work, but it can quickly get out of control. We all know that, right? Even within a vendor solution, there can be multiple products which they don't even talk the same SNMP MIBs, right? And we cannot even use the same network management solution to handle all of them. We all know that, right? So how are we going to avoid it in the SDN world? I just don't get the answer yet.
It will allow the same thing to happen as it happened to SNMP. I mean, it's very, very similar in the sense that MIBs are also published as a standard, and then each vendor adds some extra MIBs. So it's the same with Yang models. Yang models can be published as a standard, and then each vendor can just augment the existing Yang models, which are standard to do things to their device. And then if there is no corresponding data model for other devices, then you get the same situation as SNMP. Well, that's what I think with my limited understanding of Yang and limited experience.
And yeah, Lori, yes, we are having tough time extending that also, right?
Yeah.
Yeah.
Yeah, good point, Lori. Cool. Does anybody have any other thoughts on it? And we didn't, we weren't thinking about, it's, I don't know. I think we just do what makes sense. I'm not sure. I think probably the best thing that we can do out of this team and this project is kind of bring some coherency to what is network virtualization. And with that, there's going to be if we're looking for a de facto that kind of people can gel around and ideally OpenStack consume, then I think we're hopefully it's clear we're totally open-minded to anything, but as Chris has pointed out a couple times, whatever, let's be practical about it. Whatever we need to implement, we'll implement. Whatever the data path is going to support is what we're going to use. Because right now it's pretty clear that we've got lots of OVSDB support, and we've got very little OFconfig support. Has anybody dug into the details of OFconfig? As far as I know, probably the most interesting thing to me was bare metal provisioning. So that does exist in OFconfig, where it really isn't addressed with OVSDB.
To what state do you think it's not addressed in OVSDB? Just to be clear.
Oh, there's just not there's no mechanism for DHCP, Pixie booting.
Right.
So I think that's attractive. I'm sure we could probably come up with something clever, but I don't know, some kind of discovery.
And the OFconfig is based on netconf Yang, right? If I'm not wrong.
What's that, buddy?
OFconfig is based on netconf and Yang.
Yep. Right. It's containers, it's nodes, it's leafs. I guess the other would be: do we ever see a similar idea of how we've got the Yang Tools project? Does that ever make sense to have something that can generate a schema of JSON to classes when we redo classes, or when we take a look at the library at some point? That'd be a longer term thing, but I do think that would be maybe interesting. I don't know.
Sorry, sir. What is the point? You want to convert them into JSON? Yeah, is that what you're saying?
Or just like JSON to POJOs.
Oh, okay.
Yeah, going from JSON to the POJOs, that makes a lot more sense, right? So other people implement OVSDB with their own schema on their switches. Being able to pull that in is going to be pretty handy.
Well, to me, it's not a better solution than, okay, so let me explain, right? When you say JSON to POJO, that means you're talking about static binding between a JSON schema to a static POJO classes, right? Well, it's okay. Then, the problem that we discussed yesterday during the call will again proliferate here too, about the revisions, changes, and we have maintained different versions of the classes and the back compatibility issue and so on and so forth. There'll be a lot of such issues will start coming up here also, because the issue that we discussed yesterday on theory-based calls is not unique to Yang at all, right? It is unique to it is the problem of converting a model into a class, and how do we maintain back compatibility between different versions of the model? Right? It's not an easy problem to solve. It's a very difficult problem to solve, right? So the approach that we are taking now, right? We are working. Ashwin is working really hard, and we are meeting with him tomorrow to get things done there. We are not converting anything to POJO class at all. We are not trying to do that. Rather, we are trying to do it at runtime, where the device expresses the schemas, and we adapt to the schema at runtime, right? Most database centric, not converting to POJO and trying to worry about the back compatibility, right? So we are dabbling with it. It's not clear yet. So at least in my view, the conversion of POJO from the schema should not be into the base project. Rather, if somebody wants to do that, they can do it as a part of an application and deal with that. because managing back compatibility in the long run, it's a nightmare for the projects, which we don't want to deal with. Well, okay, it's too abstract. I understand that. Once we have working code, we'll share it with all of you, and then we'll deal with it. Yeah, that's the best way to deal with this one. Yeah.
So getting back to Yang, is there any merit in us looking at how we can take a Yang model of a network device and to implement that through OVSDB and not NetConf? If we assume that Yang is going to be the standard way of modeling network functionality and to be able to implement that in Open vSwitch, I don't know whether we would expect OVS to implement NetConf or whether we would do some conversion in ODL from a Yang model to OVSDB. Just wondering.
Actually, I don't know if you follow the Twitter message between. No, somebody messaged it. Maybe it's Colin and Ben Pfaff, right? They had this good discussion about the same point where they asked about, hey, we have OF config and we have OVSDB. OF config is based on netconf, Yang, and OVSDB is what it is today. What is the future hold for Open vSwitch, right? The answer from Ben Pfaff was very revealing, where he said, "No, hey, we started 2 years back. Folks are adapting to it, and show us one guy who is doing the OF config today." Right? It's a revealing fact. To me, once we start seeing folks using OF config, or once it becomes the de facto standard, then we can start discussing about this point, right? If not, we will try to go much ahead of the horse, and horse never leaves the barn. Yeah, right? So that's, to me, it's very important that we look at a practical aspect and see what is being adopted, and then bet on that.
Okay, so I'm not talking about OF config because I think that we already know that we can do all of that in OVSDB, and that maybe it's controversial to say that the battle is over, but I think Ben said it on Twitter, so I'm fine paraphrasing. What I'm thinking more along the lines of is that Yang is a configuration modeling language, and we can model things like creating link aggregations in Yang. Do we need some way of being able to take that Yang model that somebody passes into ODL OVSDB and says, this is what I want my device configuration to look like? Do we then need to go and change that and actually implement it? I'm just trying to see if there's any relevance for Yang here at all. So I'm not advocating one way or the other, just playing devil's advocate.
It is a good idea, in fact, and in fact, in one of the discussions we had previously, right, about we discussed about the library part where you need to abstract the library versus the plugin, right? The discussion we had was exactly there, where the library, OVSDB library, will always be JSON based. It will never be Yang based because the device talks JSON, right? So it's a no-brainer to talk about Yang on that layer, right? But at the plugin layer, if the folks really interested in Yang and want to do it Yang based, definitely yes. I mean, the plugin can be Yang based, and that can convert them into the OVSDB calls, which should be a JSON based, right? Definitely yes. We are not against it, and the plugins will be implemented by the interested folks. And the interested folks, if they like Yang based one, and if they want Yang based approach to be followed there, why not? I mean, definitely yes. I mean, to me, the plugin layer is placed where Yang fits with the OVSDB project. But the OVSDB library will be JSON based till OVSDB itself is JSON based, right? Which is going to be the future anyways for OVSDB. So the answer is yes. The question is, who wants it? Why do they want it? When they want to do it? Really, right? If they want to do it,
case.
Sure. The big use case, exactly. That's the use case. Yeah. So I guess it's all open questions rather than any solutions, because the reason the question also came about is because we are actually redesigning the library implementation today, and we are trying to find better answers for how to implement them better. So one thing that came very, very clear is the library is not going to be Yang based. it's a no-brainer. We don't want to have a conversion between Yang to live JSON and back, and it's a no-brainer, right? So we are implementing JSON-based schema implementation, which is already in OVSDB. We are doing it already, and we are implementing the library as a non-open data specific one. It is purely JSON, bidirectional JSON RPC based, parsing the schemas directly using Jackson. So one dependency we'll have is based on Jackson and not on open data as well. But it will be today. It will be EPL licensed, guys. So as of today, it will not be Apache licensed, where you can just not fork it off and try it using in other solutions yet, unless the TSC has different plans. So that we are doing it. We are going full steam ahead. But on the plugin side, let's keep the interesting discussion going on. If, as Matt described, right, if we want to let the network guy come into the DevOps world for programmability, if we feel that, hey, in order to get the NetOps guy get into it quicker for programmability, if you think Yang is the way to do it, definitely yes. We can have a Yang-based plugin, which will just take the Yang, convert them into JSON calls, and plug it in. Absolutely, yes. It's a good idea, actually, right? That I'm totally for it. And if whoever is interested to implement that, let's do it. Let's do it. I'm fully for that.
Madhu, this is Florian, and a bit of a dummy question here, and feel free to tell me if I'm on the wrong track. The way that I understand and the way that I look at it and the little that I know of Yang is fundamentally a different way to talking to network devices, right? So if that understanding is correct, right, with netconf and Yang and all that, to me that looks like a different southbound plugin, right, which may or may not map one-to-one to OVSDB and JSON. Right. To your point, we know that OVSDB is JSON, will stay JSON, it will be, and OS config is a different issue. If somebody wants to use netconf and Yang, that would be a different southbound plugin, which may have some overlap to some degree with OVSDB, but it's a different southbound plugin. Or did I get this wrongly?
Well, I mean, it's not completely correct because again, netconf and Yang, they are completely defined by the guy who's going to use it, because there's no standard behind. Say, for example, there's no standard OVSDB Yang model, right? If there's a standard OVSDB Yang model, that is going to be one-to-one correspondence between the OVSDB JSON based and the Yang based, right? So to answer the question, the point here is who's going to define that standard Yang-based OVSDB schema. If somebody can define it, then yes, definitely we have this one-to-one correspondence between the Yang and the JSON schema. We can convert them at whichever layer. And your point is also valid, right? Again, the plugin, when you say different southbound plugin, again, we're talking about the same thing here, right? We're talking about a plugin which can talk Yang and which can use the OVSDB library to do the JSON-based programming. That's fine, right? So if we have that Yang model, that elusive Yang model, if somebody is ready to define it for OVSDB schema, then yes, we can consume Yang on the plugin side and convert them into OVSDB calls, which library will eventually use the JSON-based mechanism to talk to each other. It's definitely possible. The question again is, who is going to define that Yang model for OVSDB, that OVSDB schema, to be precise.
Makes sense. So by that token, that would make the Yang model a superset of the OVSDB schema, right? Or something to be shared by OVSDB and potentially other southbound plugins like netconf and others, or so on and so forth, right? So fundamentally, it's basically just a abstraction layer on top of OVSDB. Okay.
Absolutely, yes. So something like abstracting multiple southbound plugins, and if you can have one Yang model which can abstract them out, yeah, definitely yes. I mean, absolutely yes.
Okay.
And with so much work we have on this project, I don't know if I mean, I personally spend time on that. If somebody is interested in that, I am definitely more than interested in working with who is going to start that thing. I mean, I think we exhausted most of this meeting on this discussion. If there's no other new points here, maybe we'll continue the discussion, man. I mean, in fact, I am much interested in this particular topic, and I want to, as Matt pointed out, right, it's very important that we bring the network ops into the programming world. If this helps, I think we should pass the work and make sure this is doable. We have to do this work, right? That's one of the most important things. And if there is no other extra points here, I am going to give back to Brent and ask him if there's anything else to share here, buddy. Brent, you are on mute, buddy. I think Brent wants to share with us on the ARP responder. We are working on the ARP responder side of the OVS side, OVS OpenVSS implementation, and we got it working as well. And Brent has it in his lab, and he's refusing to talk. I don't know why. Hey, Brent, don't be shy, buddy. What he's refusing to talk. In the meantime, I can, if you get interested, I can share the information. I mean, we have it working, and we also have the. If somebody is interested in the ARP responder, which we discussed last week, I will share the exact programming to be done to make it work. Come on. Hold on, guys. I'm searching for it. Oh God, I think I missed it. There you go. I think I got it. One second, guys. I'm trying to get the stuff in place. Oh, what happened to print? Okay, let me share my screen right now and see how it goes. Alright, guys. Okay. Can you see my screen now?
Yep, can see your screen.
Alright, great. Thanks.
Yeah, we see it.
So, if you look at this too, right? It is if you look at the top one, this is the currently used the action and I don't have the match here. I had to find a match, but it's fine. The match is similar to what you already have at the bottom. This is the current used actions, and there's a match also for the ARP responder entry that is programmed by the Neutron plugins in order to make use of the elusive ARP problem that we've been talking about, right? So we played with OpenFlow command, the OXM headers only. I mean, as you can see here, right in the top, we are seeing NXM NXM stuff and also the move most stuff here, right? With this too, you can see that this ARP responder, if you want to implement it in a perfect way, we need the NXM headers. NXM headers, as you all know, it's extension for OpenFlow 1.3. And Brent is joining. I don't want to steal his thunder, guys. Hey, Brent, you there, buddy?
Oh, sorry, I started Wireshark and X-Cords blew up, and I'm sitting there just listening to hear you. I'm like, can't touch it anymore. Anyways, yeah, I'll share it out in 2 seconds. I've got it. Just got to.
All right, Steph, okay. I'll give you the ball. This is your baby. I don't want to steal it anyway. So.
Sorry, guys. I apologize.
I'm just filling in, man. I'm just filling in. Don't worry.
Okay. So I'm just starting my mini net here quick. Okay. Hey, Madhu, did you go over, do you mind going over real quick while I'm setting it up, just what it is, what we're trying to accomplish with
sure.
Responder? Thanks.
No
Sorry.
No problem. All right. I'm back. Sorry, guys. Yeah. So, as I was explaining, if you look at the top code which is used by the Neutron plugin, you can see that there's a move instruction and we have the NX emitters. So this shows that it is kind of proprietary things used on top of OpenFlow 1.3 or 1.1. And as you guys know, we try to do everything standard-based, non-proprietary implementation. So we went back and started playing with OpenFlow 1.3, and of course, Brent did most of the groundwork. And we came with this flow, and I know this is not the right flow because I see import 1 here, and hence I need to dig up the thing, guys. Okay, so hold on for a second. I'll find out the right one.
Okay, I've got it, buddy. I'll share out.
Oh, thanks, man.
Yes, sir.
All right. So, Brent, I missed the latest one that we had. So if you can share that flow, yes, we can start going that direction. Yeah, ball is on you. You can share, buddy.
All right. So we were able to get pretty far with OXM only. Can everybody see this okay, or do I need to adjust resolution?
Yeah, we can see it.
Yeah, I can see it, buddy.
Hey, but if you cannot show the NXM parts, you can show only the OXM part that we originally had. That'll be very useful, one.
Yeah. Okay, got it.
I completely missed that part. I mean, I don't know where I know you shared with me. I missed it.
Oh, no. Okay. Let me see if this has got the OXM part.
Oh yeah, I mean, yeah, I see it there. Yeah, the second one. Yeah.
This one, yeah, that is the one.
The second one, yeah, that's the one. Yeah.
Okay, let me go to single column here. Okay, that almost fits on the screen. Can everybody see that okay?
Yes, sir.
Okay,
thank you.
Great. So with OXM, what we're doing is we're basically setting the actual ARP and the payload that's sitting inside of ARP. I think I tried to explain it to Chris last Friday, and it just made absolutely no sense. I've actually given it a little bit. I think I can explain a little bit better. But in the spec defined.
If you don't mind, can you highlight the one you're talking about, the entry you're talking about?
Yeah. Let me make this plain text.
And even starting one step before the flow with the problem you're trying to solve.
Yeah, no, that's a great point. Thanks, Chris. So right now, we flood to learn ARP. So flooding to learn ARP, ideally, we can do something a little bit better. So
the problem with flooding here is it's not just within the thing, right? We're flooding across the tunnels, all tunnels. We flood it across the network, right? We replicate on the tunnels on the head end, right? We're trying to avoid head end replication also here.
Right. Let me clean this up super quick, and if you'll go on with that, continue with that really quick. and then I will take over on the show.
Yes, sir. Yeah.
Thanks, sir.
So the problem that we have today on the Neutron implementation is that the ARP and DHCP, we are not doing anything intelligent at all. So we install a flood entry on the OpenFlow 1.3 to state that any traffic coming for ARP or DHCP, flood it across the network, and learn the way we learn today on the L2 domain. Right? Today, if you look at any L2 switch, we flood ARP, we learn the ARP through host responding, and that's it. It's as simple as that. We made it work in hydrogen release by doing that. But we all know we can do better in Neutron OpenStack, because in OpenStack Neutron, the information about every host, every VM that is being spun, we already have it. For example, the MAC, the IP address, the switch they belong to, the port they are connected to, everything we know it a priori, right? So that being the case, we don't have to follow the approach of flooding and learning, or sending it to the controller, controlling doing the proxy ARP. Now we can try to do a bit more intelligent on that. So they're looking for different solutions for that. Like we can look at the directory approach that Lisp follows today. But having a directory approach, we need to change the VMs or the host approach to change the ARP stack, right? We need to change how the way ARP works. Instead of flooding, first do a directory lookup. If it's not there, then you go and do the flooding or whatever. We felt that is a bit more change on the ARP stack on all the VMs that we have, like Linux, Windows, and whatnot. So we're looking for a better approach to that. And at the time, we found there's a solution called ARP Responder that is implemented on the Open vSwitch. So yes, we know it's Open vSwitch specific one, and since we are OVSDB project, and we are implementing the network solution for OpenStack, it's a perfect combination where the OpenStack Neutron has all the information that we possibly need, like the source IP, source MAC, IP, and the switch port information. Also, if you look at the OVSDB, the Open vSwitch has the information has all the data for the ARP responder. We thought for our project, OVSDB project, we must try to do this to make sure we can do something intelligent. So what ARP responder feature how is implemented on the Open vSwitch is pretty straightforward, where there's an OpenFlow entry programmed on the switch. The match is an ARP request match. If there is an ARP request is matched, we can do a ARP response directly from the OpenFlow entry itself on the data path. So the data path that is being implemented on the Open vSwitch today is from the user mode, not in kernel mode, but it's fine. Who cares, right? I mean, it's again on the data path. Traffic ARP request comes in. It's looked up on OpenFlow table. An OpenFlow table can do a MAC rewrite, IP rewrite, ARP rewrite, and send the packet back to the originator, saying, hey, you look for the ARP request. We have information already pre-programmed on the entry on the OpenFlow table. It's the proactive way of doing things, and we can respond back with the same entry back to the requester. So now with this information, we can use all the intelligence that we have on the OpenStack Neutron, and use the Open vSwitch ARP responder feature. Essentially, it's an OpenFlow rewrite, and we can resolve the ARP on the edge instead of sending it to the controller, a single point of failure, or feed it to all the entries and make the it's so suboptimal. So now ARP responder is a cool way of doing it. The only trouble is that we need one entry per VM for a given tenant. When we discuss with the potential customer, they don't feel it's as bad as today's flooding approach, or approach of sending it to a service node or a controller to get it resolved. So discussing with many guys, in fact, we had a big discussion on this on the channel a few days back. Many of you guys jumped in and gave a lot of good feedback on that, so thanks a lot for that. Now, with all this information available, the implementation available, and a lot of thought process and discussing with the customers, we felt we can implement ARP responder in the OVSDB project ourselves. So that's the background.
Thanks,
That's
buddy.
the
Appreciate
image
it.
that we have. Yeah.
And
so
does it cover it, guys?
Just to add like a tiny, sorry, I was up and I had to power on a machine when it X locked up. So instead of us having to do a packet in for ARP resolution, so normally, like in the traditional OpenFlow, right, a packet comes into the data plane. The data path is going to say, well, I don't, because since the data path is dumb and it only knows about flows essentially, it's going to have to punt to the controller to try and figure out where the ARP, who's going to resolve ARP. So we keep that in some kind of map in the controller. So right now there's kind of inherent scale problems to that because, I mean, in the bigger picture, that probably scales more because we can always scale out compute as opposed to scaling out memory. We couldn't have a host even distributing flow ARPs in a single entry across 200,000 hosts. Well, that would blow up the forwarding table on the hypervisor. But for right now, we think it definitely makes more sense to distribute that out to the edge. So instead of an ARP packet having to go, us doing a packet into the controller, we're saying the ARP's going to be answered on the edge. So we're going to distribute that out. So that also is implicit that we would have to populate entries. So if you had 10,000 hosts on a network segment, that's going to have to get populated out and distributed to those hypervisors also.
Can you go back and talk about the scalability concern you had? I'm curious what you think about that. Like if you had like 1,000 VMs and those all have to be proactively put into the flow table to answer ARP, what are your concerns about that scalability?
So my concern basically was it's a memory, right? Again, right? So with Open vSwitch, will it cause any memory exhaustion by having all these program entries? And that entry, as you can see, is not a data-heavy entry, right? It's just a control entry where it might help on ARP resolution. After that, it's going to be so idle, right? So, but it's going to stay on the user space, not in the kernel's data path thing, right? That's one good thing. So personally, in fact, we asked Ben Pfaff also, right? In the email thread about that. He didn't show any particular worrisome about the scaling issue on the flow table, the user space. And one more thing I want to add here is, it may not solve everybody's problem, right? Some use cases might be more fitting than others, right? Say for example, NFV, right? In NFV, a given OVS instance is dedicated for a particular mode, a role, right? Instead of sharing with multiple nodes there, so it might be a better fit for some use cases. While if you want to cram multiple functions in the same node, like the OpenStack use case, right, where I have tens of thousands of tenants on the same node shoved inside, and also sharing with Open vSwitch instance there, it might be a bit more, customer has to decide which mode they want to take, right? So personally, if you ask me, I get a lot of echo there. I don't know where it is coming from. Now it's better, I think. Yeah.
Cool.
No, it's not. It's fine. So the way we are implementing it is we are planning to implement it as a app on top of the OVSDB, where the app will get a request for the ARP, and then it will pre-populate ARP entry. By doing that, this app can be installed on some use cases and not installed on some use cases. It's going to work either way. So that's the point.
I guess the scalability issue, we talked about expiry. I mean, that's kind of like a knob you should be able to turn so that if you have an awful lot of ARP entries and you do have a limited amount of memory, you just you tune the expiry of those entries so that they go away after a while, because realistically, you don't always need them there, and when you need them, you can regenerate them on demand.
Sure, yeah. So the problem here is we're talking about a proactive way of installing it, But the moment we say that we'll install when needed, it becomes reactive. But yeah, sure. I mean, definitely yes. I mean, that's one way of doing it is to have a expiry mechanism to that. Yeah.
It's kind of like if people want to have this capability, they install the app, and then they can tune the utility of the app based on their scalability needs. There's no like, it's not binary. Is all I'm saying.
Well,
yeah,
and,
that's a very good point.
and I think our goal probably with this just out the gate is we want to have an implementation that's purely proactive. So the controller can crash, everything can crash, but forwarding still occurs on the edge. So I think more than anything, this is just us kind of playing it safe early on.
But how realistic is that? Because when you have changes that occur, the controller has to be there to implement those changes anyway. I mean, really, the controller can't really go down for any length of time without impacting other, like having other impacts. So.
Yeah, sure. I mean, yeah, the headless operation is a bad idea per se, right? So I think what Brent is trying to say here is when the controller goes down, we are having a clustered solution there, right? But in a clustered solution, we do a hitless operation. But hitless operation is very, very, very difficult to implement in a clustered controller solution. So in those conditions, such solution will really come to a lot of help. So we can be hitless by doing proactive installation, and also having a cluster solution on top is going to solve the problem that we're talking about now. Definitely, yeah.
So I have a question related to that. Is there any option to change expiry handling when the controller is not actually in communication with the switch? That would seem like an obvious use case.
That's a good point, yeah. That's a very good point, which we haven't implemented, but is an excellent point, yeah.
Is it anything that OpenFlow supports, is what I'm asking?
I mean, OpenFlow supports
OVSDB?
expiry.
Yeah.
Right, but does there conditional expiry based on connection to the controller? Sometimes you want it, sometimes you wouldn't want it, you know? I mean, the whole idea of having...
OBS has a fail mode.
Yeah, it's called secure fail mode, yeah. Fail mode secure or fail mode standalone, yeah.
And does that allow you to conditionally have flow entries expire or not expire depending on that setting?
It is not conditional per flow, rather it's conditional per bridge, yeah. It's a global one.
Oh, okay.
But per flow, you have this timer expiry and hard expiry, where you can say, no, expire after this time if this is not used. And hard expiry is when it doesn't matter whether it's being used or not, you expire on a given time, after a given timeout.
So I mean, all I'm saying is the whole idea that we have to be totally proactive. It would seem that it's possible to be reactive using those soft expiries, and then using the if you don't have a connection to the controller, then don't expire them. I'm presuming that's what it should be possible to do that, right?
Yeah, I mean, yes, definitely, yeah. So if the connection to the controller, we can, if you say the fail mode is secure, that means you're not going to time out when the controller connection still goes down. And if the connection goes down, then we'll expire it.
Granted, that doesn't give you... Sorry, go ahead.
Sorry, I'm just jumping in there. I'm just thinking about how we actually do reactive mode if the controller's down. You know, if the MAC address isn't actually on this host and we need to pop in the MAC of the VM which is on another host, we've lost that canonical source of information there which has all of the location information. So at that point we'd have to revert to flooding, right?
Yeah, yeah. So good point, Dave. So the plan that we are having now is we are going to have the flooding entry as a low priority entry is going to be there always. On top, we are going to have this ARP responder application to install these ARP entries. So we have this backup plan. If the ARP entry is timed out and if you want to get the ARP, we'll flood it and learn it. So it's fine. We are still on the data path. We are not screwed up yet. So the plan should go with that idea. And the point that Maru brought up is also a very important point there. That yes, we are concerned with scale, and with the timer expiry mechanism, yes, some cases we might do a flooding, right? If unfortunately that entry happened to be expired and whatnot, right? But if you have a proper good implementation there, right? Good implementation about based on I'm missing the word. Good word. Based on the existing how it is being done on the path. If you have a lot of hits on a given ARP entry, don't expire, keep it there. If an ARP entry is really not used much, we can expire it and hope no, the Friday entry might come to a saving that thing. So things like that.
Talking this through, I'm wondering whether it might be more sensible to do something in OVS that actually implements an ARP cache. So what we do is, rather than taking the packet ins or looking for something that's sending an ARP request, if we actually cache the responses and just use OpenFlow to generate those locally, that would be a much more failure-tolerant solution, because we could still revert to flooding, and then we just cache the ARP response as it comes back and serve that locally until the point when it times out. And then we wouldn't need to pre-populate all of the ARP tables.
Yes, it makes total sense, and actually this is the issue that I'm having as well, right? So to the earlier scenario that you have 1,000 VMs, right? But most of them are dormant, and the ARP is only done dynamically and only if needed. And now suddenly, if you are being proactive, you need to pre-populate all those entries, worry about the expiries, and so on and so forth. Whereas if you cache, right, which caching is still a form of reactive mechanism, well, you don't have to flood all the time. So it is a sort of optimization, but it's a posteriori as well.
So what's the difference between caching and proactively loading? Help me out with that. Are you saying in a failure scenario?
Yeah, so dude, what I'm thinking is, rather than, because what we're doing right now, I'm guessing, is that we see an ARP request that comes in, and then we just essentially do a modification on the packet and spin it straight back out again with a response, right? And that's what we're trying to do here.
So what you're saying here is we are talking about an ARP proxy implemented on OpenVSwitch, not necessarily OpenFlow-centric one, but a feature in OpenVSwitch itself, which will listen to the ARP exchanges between the VMs and start caching it locally, and will start doing ARP proxy for the VM locally, right? That's an excellent point as well. We're talking about an OpenVSwitch use case, OpenVSwitch feature to do ARP proxying there, right there. Is that right?
And I think the important thing to point out
now you
is
have more problems. So.
This doesn't require an agent, and this is all native. So I mean, we're kind of we're leveraging tools that exist there. And we're still kind of keeping true to what I think one of our main goals is to have an agentless deployment.
Right, but this is again agentless. We're talking about. I mean, I think at least Dave and Florian are talking about a feature in OpenVSwitch itself. Like, say for example, if 2.2.0, if some of us can develop the ARP ARP proxy feature on OpenVSwitch, then we can get it without needing any agent on that.
Yeah, I guess the other thing that I'm thinking about in this implementation is just something simple like ARP expiry. We can't have these flows expire because we won't be able to rebuild them again, because I'm assuming that we're building them when a VM spins up.
What? Well, we could always. I mean, we could have a flow mod in the data path that says, that's just a lower priority to punt the controller. So we could periodically expire.
I don't really understand that argument at all. You're going to have some sort of thing that is managing the networking, and you're going to know. You don't have to worry about it just on VM2. I must be missing something.
I think he's saying so. What happens when a new node comes up? The cache expires, the flow mod expires out, and then it needs to start doing traffic again. So something has to notify the controller to install that flow mod. So that would be a packet in at that point.
So yeah, I mean, Brent, that's the reason why Dave's point is more solid here, right? Where if you have an ARP proxy mechanism, right, the advantage of that is we flood once, of course, and once we learn it, we don't have to flood again, right? So we reuse it. So it's the best form of using the OpenVSwitch edge intelligence intact and making use of it, rather than even involving controller or OpenFlow or anything like that.
Mm-hmm. Well, it might be interesting to put something in user space that's not going to be certain.
I guess I just don't understand why there's one way to do it. There's a whole bunch of ways. It'll depend on the scenario. We want to be proactive in some scenarios, reactive in others. Some people might want an agent because they don't they have too many entries to stick an OpenVSwitch.
Well, the problem with reactive is you'll get to a point where you overload the controller, right? But with this
potentially,
case, it's distributed and reactive. Exactly.
Right.
So like if you have a local cache, you're being reactive about it, but it's in a distributed fashion. And it also plays really, really nicely into, and I gotta say it because whatever, but in terms of feature parity with IPv6, it also plays in very, very easily. All you would need at that point is a multicast listener on the vSwitch, and it does exactly the same thing. What groups are you a member of, and that's basically how ARP in IPv6 works. So that model actually is not only, it plays nicely into the future when we need to know IPv4, we'll be able to do that.
Yeah, I mean, personally, I like this idea a lot. I mean, Dave and Ryan, it's a great idea, actually. So.
Yeah, very cool.
But dude, what you've done here is awesome. You know, let's not take away from that. I want to feel like we've just derailed the discussion here. So.
Oh no, Dave, you're going to implement
awesome.
this, right? The reason we are saying all the accolades to you is because you're going to implement in Open vSwitch, and we're going to make use of it, buddy.
Lori's good at. Lori's pretty awesome, so he can help. Just kidding, Lori. Sorry. The other, I think we're thinking of just something that's fairly reasonable short term. Actually, Lori, if you're still on, I would like to hear your thoughts on that, though.
But Brent, I mean, what we have here, I think we should anyways go and implement it because we don't have it. It's still in WebEx talks right here, right? So until it's getting reality, the best option we have is this is one of the good options we have, which customers have actually expressed interest in this one, right? So that means we have to go and do this.
Don't get me wrong. Like, this is real. Like, we have to do that.
Right, exactly. Yeah. This is real, yeah.
You know, there is totally room for multiple implementations with, you know, a config file selection for which one you want to use, because as Madhu said, you know, not everyone is going to fit every use case.
Mm-hmm. Right. Well, and I think the whole point, like, when we kind of kicked off and put this on the roadmap, that was the whole point of this. I personally think this is the crux. This is so critical to just everything in SDN. If you understand ARP and somebody has to answer it and where that gets answered and the implications on distributed systems from that, which none of us on this call can wrap our heads fully around all the implications of that. So if we all kind of knock heads on this, I think we can solve really serious problems in networking, or at least try and capture a lot of the use cases.
And one more thing, Brent, is that I think this will directly feed into our solution for the distributed virtual router also, right? Because if you look at the routing today, it's all centralized way of doing it, and there's no good solution there. And we also saw the presentation by the OpenStack team a few days back, who kind of explained, who are trying to take a similar approach on the distributed virtual router by an agent running on the routing agent running on each edge box. So I think this kind of a discussion here that we are having here will really play nicely with the distributed virtual router as well.
Yeah, and I think one thing, I mean, the last thing, I don't beat this to death, but the last thing is, I think we also need to think of, in the back of our heads, a solution that may not involve the management plane, because I also think that might be important to the world.
Agreed. Dude, just wondering, do you know if this is gratuitous ARP safe as well? So whether we can actually update entries in the table based on a gratuitous ARP?
I think so, because if you look at the lookup is not even based on the ARP type.
Cool.
Yeah.
And so,
but that's a different type of ARP message, right? That's not supposed to be responded to. That's a client saying, "This is my IP address, Mr. Switch." Update,
I know.
Sorry, this is my MAC address IP. Update your information, everybody else. So yeah, that might be something that still needs to be flooded, because I'm guessing again we need to think about client-side ARP caches as well, because don't forget that even network stacks and servers cache ARP entries, and maybe gratuitous ARP causes them to refresh those when they get something else that's come through there. So that might be something else that we need to think about, especially in cases where, you know, somebody's using VMware as a hypervisor and vMotioning all over the place.
Mm-hmm. Well, and aren't those are significantly more programmatic than just flooding, right?
Oh, gee, with you on that.
Yeah. No, I'm just so we haven't. So what I'll do is really quick, just demo it, and then so that way we'll hand it off and it's interested to work on this project. That way you can get it banged up, started in the lab. Just really quick, I just wanted to show when we were talking about what we do today. So here's the flood. So we've got an ingress and egress flood for local VMs and for the OpenFlow tunnels. So here's a flood to the tunnel that sits table 1, so everything destined towards the tunnel. So we've got these 2 ports here. Output 10 is going to be an OF port, an open flow port that's going to a tunnel destination, and so is 11. We also took drain at the table 2 just because we think it makes sense to run out the table. It may not make any sense, so if anybody has any input or thoughts on that. And then the local VM, the same deal. So if we're flooding in table 2, so the last was table 1. In table 2, we flood towards the VM. Now let's go into the new fun. So we actually got it working with OXM only, but the problem is it looks a little weird when your source and destination MAC are the same. So, I don't know. So if anybody's got any trickery that they can figure out, that'd be awesome, but we don't see a way.
I think this is what we were talking about the other day. Can you elaborate on that a little bit?
Yeah. Didn't quite look.
Can you use set field instead of load here in the flow definition, since you're using local for 1.3? It would look a little bit less weird, I think.
Yeah. So in the data path, or so the actual in the user path and user space on the switch on the vSwitch itself, it actually does show up as set field. Well,
yeah, so actually, if you look at the load is set field, so that's
yeah.
fine. I mean, so that is okay. The problem is the move, so that's where the problem starts.
Yeah, no,
you can see move restrictions.
I'll add this other one in at the end. You'll see where it says set field.
Yeah.
So, yeah, that is the same. You're right. It's just semantic. So here we have just these 2 rules. So then the other nice thing I think we've already pointed out is just 1 flow mod per port. We could definitely probably hack that up enough with enough mods to get it working with OXM only. It's going to be, I think, what did we figure in squared? It's not going to get. It's going to get nasty. So rep-a. So these are just the 2 bottom hosts are VMs. So just Madhu likes to make sure I'm not cheating, and it's often good that he does. So no ARP.
Don't take it too personal, man. Yeah.
No. Well, 9 times out of 10, that's actually good, right? And then here are the 2 ports. So these 2 ports have the VMs hanging off of them. Anybody want to see more details? Here's the config itself. So just two NICs sitting on a bridge named lib, because I'm lazy and just wanted a 3-letter word to type. So we'll ping.
So, but before pinging, can you make sure the stats are not updating so that we make sure the stats are updating on this one?
That's the one I'm thinking of. Highlight it there. So we got 16 and 12. See that?
Perfect, sir. Thank you.
All right, buddy. So it's not going to have a reply, but flow mods in. We just want to see the ARP.
Yeah.
So a couple packets. Now we've got an ARP. Of course, not here yet. So I'm going
to. Before doing a ping there, right? Can you? Oh, sorry.
Oh,
it's okay.
Sorry.
It's okay. It's okay.
So yeah, so we've got counters. Yeah, you're talking about the. Okay. Yeah, perfect.
Thank you. Thank you.
So that's it, guys. Exciting, huh? And so what we're actually, yeah, it was actually pretty awesome. So here are the OXM fields, just to review them super quick, because we're not setting the outside header. We're actually setting this is what we want the ARP to look like that gets encapsulated. So we're setting source test, MAC address, and source test IP. Cool.
Perfect.
All right, awesome. I'm going to do this in a gist, and then we'll get it out to everybody, obviously. But
hey, thanks, man. And we are just half an hour over time. Not more than that. It's okay.
Yeah. Sorry about that, guys. Hopefully this was okay. I'll put it into the chat here and stop sharing. Gist is in the chat if anybody wants it. Oh gosh, that's a gist to a gist. Sorry.
Yes, sir. We got it. Thank you.
I encapsulated the gist. Sorry.
Oh, come on.
I couldn't help it.
All right, sir. Thank you.
Oh, yeah. Thanks, man. All right, guys. Well, thanks, everybody. Hope this was okay. And
is there anything else that folks want to discuss, or we are done for today?
So we put a fork in this bad boy.
Yeah, thanks for the demo, Grant. That was awesome, dude.
Oh, no, sorry. I had to, yeah. Mr. Wright, you got anything for us, sir?
No, I was just looking at OpenDove just now, and it looks like it's doing the exact same thing. So the only part there is an ARPD that you can run in user space, and I was trying to picture if we could run a multi-tenant ARPD or an ARPD that's listening on a tap port, kind of how DHCP or DNS mask is working, so that we could build, pre-populated cache without any OpenFlow rules, and just have a single rule that points to the ARP cache, essentially. So the ARP user space ARP daemon replies. But I don't know if that would end up being easier or more complicated.
Nice. And there you have it. If you have a boss at Red Hat, they're equally the smallest boss you'll ever have.
I don't know about that. I do know I'm jet lagged. So,
so Chris, are you back?
Be glad to drop. Sort of. I'm in New York. New York today and Boston on Thursday and Friday, and then home.
Oh, man. Yeah.
And Matt, thanks a lot for helping us kickstart the discussion, buddy. So that's very most important discussion that we want to have right before the Helium release. That's good. Thank you.
No worries. I'm still doing research.
IPv6.
What's up?
Don't stop with the IPv6 comments. They're very highly warranted.
Okay. If I don't, Ed Horley's going to hunt me down. So.
Right.
I was going to say
pure survival instinct.
Awesome. We'll have to tell Ed to watch this. That's funny. Thanks, guys.
All right.
Appreciate it, everybody. See you guys.
How do I stop recording, guys? I hate this one.